What we're going to be talking about today is OS 10 development for C++ programming. And I just wanted to share with you some of the technologies that Embarcadero are building right now in order for you to do that. So how can you be doing your development on Windows, and how can you then take that to OS 10? Just before I begin though, I overheard a couple of words there about Embarcadero. A lot of people don't know who we are. So when I introduce Embarcadero, I normally start by saying, have you heard of Borland? If you've heard of Borland, such as Delphi, C++ Builder and so on, then you know who Embarcadero is. There's another part to Embarcadero also, and that's around multi-database platform management. And so we've got a number of tools and capabilities to help with database administration, database development, database optimization, change management or version control for databases, and also designing databases, whether they be data warehouses or relational transactional systems. And obviously we have our highly productive integrated development environments or IDEs, such as C++ Builder, Delphi, and so on and so forth. So, with that out of the road, I wanted to talk about this interesting thing called FireMonkey. I've heard some people talking around saying, what is FireMonkey? I saw you looking at the banner out the front. Is it a product? Is it a technology? What is it? Well, I'm going to explain that to you now. And we're going to be talking about our next generation platform for application development. That's what FireMonkey is focused on. So FireMonkey is an application framework. So for those that, I think there's a lot of people here that use MFC, or you've heard of the Visual Component Library. If you've been doing development for many years, you would have heard of the Object Windows Library as well. But FireMonkey is essentially an application framework. It's built directly into C++ Builder and into Delphi. And by using FireMonkey to build your applications, it enables you to target multiple platforms. So from a single code base, you can target Windows 32, Windows 64, OS 10, and in some cases iOS also. So FireMonkey is a very, very new technology, but it's a very exciting technology in what it can provide for your applications. All of the controls in FireMonkey run natively on those operating systems. But we do things slightly differently. We aren't making direct calls down to the underlying operating system to create those controls. We paint those controls ourselves. And depending upon the operating system that we're running on, we'll use a number of different libraries in order to achieve that. So for example, under Windows, we'll use things like DirectX, GDI+, and so forth to render our Windows user interface controls. On Mac, we'll use OpenGL, and on iOS, we'll use OpenGL ES to build those controls and to render applications on those frameworks. The beauty of this approach is you don't need to understand DirectX, GDI+, OpenGL, or any of those underlying layers. FireMonkey handles all of that for me. Now there are many other frameworks out there today that are cross-platform, that do enable you to get to all these platforms. But typically they fall into two different camps. One camp is what we call rich internet applications, so RIA type applications. And the other type of application is essentially translated through a virtual machine or a CLR, very much like, say, Java, or for running .NET on Linux through Mono, and those sorts of technologies. One of the big challenges you have with those sorts of frameworks is performance. For applications that need to do very heavy lifting, you know, number crunching, analysis, data connectivity, whatever they are, sometimes in those RIA applications and virtual applications, performance isn't what it could be. But with FireMonkey, you get native performance. It runs natively on Windows and on OS X straight away. The other interesting thing about FireMonkey is we use a combination of the CPU and the GPU also. So we are taking a lot of workload off the CPU for all our graphic rendering and image rendering and placing that on the GPU. And so all your business logic, middle tier components and so forth will run as fast as they possibly can depending on the hardware underneath. So what I'd like to do now is just point out some of the key features of FireMonkey, and then we'll start looking at some examples and actually get into some source code as well. The first area of FireMonkey are what we call HD or high definition forms. Our marketing department got a hold of this, hence the reason they're called HD, but think of this as being two-dimensional or standard forms. Underneath, when you build your HD forms, all of our user interface control are vector-based. The importance of being vector-based means that if you need to magnify your screen and change resolution, your images and controls will remain crisp and clear every time without any pixelation at all. So that's one of the big benefits of FireMonkey to begin with. Out of the box, even though this is a version 1.0 framework, we have many user interface controls. Pretty much for both OS X and for Windows, you have all that you need to start building applications. And the nature of how FireMonkey works means that you can build your own custom controls very, very easily and very effectively. If you don't like the way the FireMonkey controls look on your form, there's a style engine underneath. And we provide a style designer so you can change the look and feel of all of your user interface controls so they meet all of your customer demands. We also provide many different effects that are simply drag and drop onto your controls as well, which means you can make some very nice head-up displays and get some very nice effects for the application also. And we'll cover those in a little bit more detail throughout the presentation. The other exciting component to FireMonkey are three-dimensional forms. Being able to render 3D objects in your application and manipulate them many different ways is a brand new feature as well as in FireMonkey. Again, these 3D forms are all powered by the GPU, so your application can focus on processing all the logic through the CPU. With FireMonkey, we do make calls through the FireMonkey layer down to the hardware layer so that you get lighting, textures and animation automatically. The interesting thing with the 3D forms is they can also contain HD or 2D user interface controls also. And we'll walk through a little bit of an example to show you how you can quickly and easily put those things together. Now my favourite part of FireMonkey, the data visualization aspects. This is where we start talking about what we can start to do with our data sources and how we can apply that to all this rich user interface functionality FireMonkey provides. We typically work with data in a client server or a middle tier application where a user is presented with a form, they fill out the details, they run a report, but traditionally it's been in very two-dimensional space. All of a sudden with FireMonkey, we can start developing applications that use our data in 3 dimensions. And so, for example, we can start visualizing in this particular example here, populations of certain nations based on the depth of an individual map. Or for those that are doing engineering and scientific calculations, calculating 3-dimensional equations, performing wave interference patterns, and so on and so forth. Even the ability of developing technologies for games and those sort of things are quite possible within FireMonkey. In previous versions of our technologies, in order to provide effects and animation to your controls, and I'm sure you've seen this in the technologies you use today, there are many algorithms you need to either write yourself or purchase to be able to get what you want out of the application as far as look and feel is concerned. Out of the box within FireMonkey, we provide many different effects. Effects such as reflections, such as glowing, crumple effects to make a memo field look like a scrunched up piece of paper, whatever it needs to be. There are many different effects that are all very component based. We simply drag and drop them onto our form to build our user interfaces. Aside from the effects, there are also many animations that you can provide. And again, these can be written in code or can be applied through components also. And we'll have a look at a number of simple examples to give you an idea of the kind of capabilities we have within FireMonkey. So with that, I'm just going to drop over into C++ Builder, and we'll have a look at putting some of these really simple things together and have a look at both 3D, 2D components, some effects, and some animation also. And I've lost my resolution. Okay. So can you guys hear me up the back all right? Yeah. Okay. So all I've done is I've started up C++ Builder here. And within C++ Builder, I've just gone into the File menu, then into New, and I've created a FireMonkey HD application. And that's created over here on my right-hand side, my executable, and what we essentially call a form. And the form is my user interface. And this is where I can start creating my look and feel for the application that I want to build. We're going to look at a number of different components with this. And what I'd like to be able to do is start with some three-dimensional components and then add some two-dimensional components to control those three-dimensional components. In order to access 3D objects in a 2D space, we use a component called T-viewport. This enables me to embed 3D objects into here and control them like a 3D object should. And to provide a little bit of standard look and feel, I'm going to lay out my components using what we call a layout. So if anyone has been exposed to Java before, Java has the concept of layout managers, where we use it to define where our controls sit on the UI. This is very, very similar to that paradigm. So I'm going to take my layout, and through my object inspector down here in the bottom left, I can control different properties of that without having to code. So the first thing I want to do is change the alignment property to AL left, which will snap this to the left-hand side of my form. And no matter how much I resize this form or shrink the form, it will always stay aligned to the left every time. And for my T-viewport, we'll align that to what we call the client. So the rest of the space, which isn't being consumed by any other layout. So in order to use 3D objects, we need a 3D shape to work with. Within FireMonkey, we provide a number of what we call primitive shapes, or building blocks, that you can then build your own custom shapes from. So things such as cubes, spheres, cones, and so on are what we classify as primitive shapes. So I'm just going to take a T-cube and put that onto my form. At the moment, it just looks like a square. We're going to apply some light to that now, so we can start looking at it in the sense of 3D. Another component that I use when I work in the 3D space is a T-light. And I take my T-light and place that on my form as well. And I'm going to move that over to the corner here. And you'll notice that as I'm moving it, my cube has started to change shape because it starts to understand how light reflects off that object and diffuses it. But let's have a bit more of a muck around with our shape. Let's make it a little bit bigger. Let's rotate it around a little bit more. So we've got something a little bit better to look at. Now, with our cube, we want to change, it's a bit boring just being black. So if we choose our cube, there is another property in here called material, down here on the bottom left. I'm then going to change the 3 levels of material. So our diffuse colour, we'll make sky blue. Our emissive, we'll make, no, we won't do white. Let's do teal. And ambient, aqua. I'd like to point out that I am no interior designer or decorator. I have no colour sense whatsoever. That is my wife's job. So, this is the cube we're dealing with. And you can see here that that cube now starts to have a bit more of a 3D look and feel. Another optional component that you can apply now is something called a T-camera. And the T-camera determines how we look at those 3D objects. By default, there is already a camera of it as part of the viewport, so I don't need to apply one. But I could have many cameras and can control each of those cameras just by accessing them through their properties also. So there's our very simple 3D object. But now, let's animate it. Let's do something to that object. So, I have something here called a T-float animation component that I simply drag and drop onto my form. Up here in the top left, I have something called a structure pane. And the structure pane shows me the hierarchy and relationships between all the components on my form. I'm going to take the float animation and place it under the cube so it becomes a child of the cube. I then want to define some animation properties for it. I'm going to determine the duration that the animation runs for as 2 seconds. What I'm actually going to animate is found under property name. And I want this cube to rotate around the y-axis. So we have a property here called rotation angle.y. And we choose that as our rotation angle. I'm going to start from 0 and I'm going to go to 360. So all the way around. Let's loop that as well. So it'll just continue to run. And let's run this now. Oops. It might be helpful to enable it. And there we have a very simple 3D object just running within our form. So let's add some 2-dimensional components to that as well and look to control that. So I'll switch off enabled here. I'll go to my tool palette and add a T button. And I'll place that over here in this layout. In here, I will double click to create my event handler. Any code that is called from here will happen when I click that button every time. I go and choose my float animation. I find its enabled property and I set that to true. So every time I want to start this animation, I can click this button. Let's also make this button look a little bit different. And let's apply one of the many effects that are in FireMonkey, a T-glow effect. So I take that, place that on the button, and now my button has a slight glow about it. And we can go and change the colour to be green. We could use this, for example, to wrap around an edit field. So if a user's forgotten to fill in a mandatory field, it could glow red. We could even set an animation so it fades in and out on the opacity property also. There are many different ways that you can apply your effects and your animations. And now if we simply choose this and click the button, our component starts to rotate, and you can see here through FireMonkey that we're running here with a 3D object. But part of this presentation is also about OS X. Everything is running on Windows right now. So how can I take this application as it is right now and move it onto OS X? Part of your installation with C++ Builder is something called the Platform Assistant. And the Platform Assistant runs on all the standard platforms that we provide. And this guy is responsible for taking and deploying my application, in the case of a test, for example. So I'm going to start my Platform Assistant. It's prompting me for a password, so I can control who has the ability of deploying to particular machines in my organisation. We're all friends, so I have no password. And it'll sit here and run on this particular port. Let's go back to C++ Builder now. And in my project, I have this option here called Target Platforms. And currently, it shows 32-bit Windows. If I right-click and say Add a Platform, I can select OS X as my platform. And it will then associate this thing called a profile. If I go to my Tools menu and into Options, I have something called a Remote Profile. This is a list of all of my platform assistants in my organisation or in my development environment. And I choose the one that I want to be able to deploy to. And that will then deploy on to the appropriate operating system. Our test connection has succeeded. Choose OK. And now it's a simpler matter of running it. It's going through the process of compiling it, building out the appropriate libraries. And now if we switch over to OS X, there is my application without making any changes to that particular code base. And again, if we run, this is now using all the underlying infrastructure of OS X to then build those components, define those effects, and perform that particular animation. Now the thing about C++ Builder and about FireMonkey is it's not just about the user interface. Our focus today is on the user interface because we want to be able to demonstrate to you how you might take some of your existing C++ code and interact with FireMonkey with that also. But through FireMonkey, you have database connectivity that is also cross-platform, except the ODBC option that's defined up there as well. But through our database connectivity, you can connect to many databases on many platforms, either on Windows or on OS X. You've also got the ability of accessing clouds in the objects in the cloud, such as Azure services and Amazon services. So part of our C++ offering as well is this ability of being able to build multi-tiered applications that can be deployed to the cloud and can be consumed by multiple user interfaces, whether they be on Windows, OS 10, iOS, Android, and so on and so forth. So to begin with, I hope that's given you an idea of the capabilities of FireMonkey. Normally this presentation goes for 3 hours and we're trying to condense it into 50 minutes. So I hope from the session so far that you've seen FireMonkey is a native cross-platform application framework for Windows, OS 10 and for iOS. You've got the ability of being able to build 2-dimensional and 3-dimensional applications through FireMonkey. Effects and animations are very simple to apply, and the coding that I've done so far has been pretty minimal. You can easily connect to all your data and services that you have, and we'll demonstrate that a little bit more throughout the session. And really, to sum it up, FireMonkey is the application framework for next generation business systems. So with that in mind, what do Visual Studio, Visual C++, and other C++ developers gain from FireMonkey? What are some of the things that you can be doing today to be able to access and use FireMonkey if you have the need of getting onto OS 10 without having to learn yet another language? Some of our initial research has been looking at a couple of areas with how we can start to achieve that for you guys. What we want to start to do is provide an ability for you to take your efforts that you've been doing in, say, Visual C++, and providing you a mechanism getting those onto the Mac platform. I've got a very simple example to show that in a moment. But we also want to have show you the ability of being able to take a web service that you might have written in C# or in C++ on the .NET framework or on any other platform, and consume that as well through FireMonkey, and implement more information around that using your C++ skills as well. And finally, if the need arises to be able to take an existing Windows application and add some interesting FireMonkey components to it, how might you do that through the use of things like shared libraries as well? And we'll have a discussion to finish up the session on that. Everyone has asked us, why are we looking at Mac as our next platform? Why is Mac so important, and why is Windows so important? Currently today, Windows is still the leading desktop platforms in organisations. But it's very interesting to see the rapid growth of OS 10 devices in organisations as well. In the third quarter of last year, Mac sales were up almost 25%. Compared to the 5% of all desktop PCs that were shipped. And a lot of those aren't going to the consumers either. A lot of those are being used in business environments. Apple is soaring to third place in the PC market with a 10% share of that market space, which is big in the short time they've been doing this. And what's also very interesting, I've noticed so many people here today that have got a form of tablet, an iPad, and things like that. Getting onto OS 10 is also the way that you can then get onto iOS and start providing your systems on mobile devices also. So the next demonstration that I wanted to show you this afternoon was how you can take some Visual C++ code and be able to use that on the Mac using some FireMonkey and C++ Builder. So, I'm in Visual Studio here, just version 2010 to begin with. And I have a very simple application. But the whole idea is to prove a point, to show how you can move things from Visual Studio into FireMonkey and start using them on another platform. This application is simply an order entry, where we have a number of objects which represent customers and orders and products and how they relate to one another. And so here, for example, I have my customer class, and I'm simply creating an array of customers. And then I have all the appropriate getters and setters to retrieve the individual attributes of that customer. I do the same thing here for orders. So I've created an order array, stacked it with information, and then I have all the appropriate properties of accessing those. We're dealing here with essentially vanilla C++ objects. And the same thing goes for product also. And then I have a customer dialog, which then simply uses each of those objects and populates a list box for me. So further down here, I have my on button click event, and we go through the process here of creating our customers, instantiating a list, and populating that list. And so if we were to run this, we have our Visual C++ dialog. I load my customer orders, and there they are. Pretty simple. Now, what I want to be able to do is transition this into FireMonkey. Now, one of the things about this particular application is we have a clear separation between our business logic and our UI layer. And that makes things very, very easy for us to transition across. The only thing that you as C++ developers need to come to grips with is understanding the FireMonkey component library, because all of your C++ skills will transition across. So with that, I'm going into C++ Builder. I'm closing this particular project, and I would go File New, and again, we'd create a HD application. So I've just started to build this already. I've just created my form, and what I've done is I've used version control to check out those 3 object files. So my customer, my order, and my product, and their associated header files. And I've checked those into my project folder in C++ Builder. Now what I want to be able to do is add those to my project. So in my project manager on the right hand side, I right click, choose the option to add, and then choose my 3 objects. So we've gone and added those now into our particular project here. Now, some of these actually do use some MFC classes. So you'll see here we're using standard AFX.header file. So what I want to do is just comment that out on each of my classes. So that's our simple part. So we've gone and added our existing C++ code. We've just commented out the MFC because we can use FireMonkey then to generate our classes and to also use the underlying data types that FireMonkey supports. And now our next step is to start constructing the user interface. So I jump back into my form, and here's my UI here. And what we're going to do is grab a T layout, place that on the top, align it to AL top, and inside that we'll place a button. And then what we'll do is we'll add another T layout, align that to the client, and inside here we're going to add something called a T list box. So that will just sit in there. And what we might do is to make that sort of sit in a nice sort of border, I'm going to muck around with the layout and change some of what we call its margin properties. And so I'm going to put a margin of 10 on every side of that layout, which means when I go to align this control, it'll have a nice border 10 units around that particular layout. So I'll choose now AL client, and I now have that nice little border around it. Let's add something else, just for fun. A T-crumple effect. Okay. Now it makes things a little messy to begin with, but what we'll do is we'll put that into our list box, and the progress is set to 30, which is ridiculously high. So we'll set it to 2. So we've kind of got this uneven border around our list box now. So we've created our user interface. Now what I want to do is, before I start accessing those objects beforehand, I just need to include the header files for each of them. So I'll just jump into my C++ over here, and we're going to include customer.hppp. We're going to include order, and we'll also include product.hppp. So we've added our header files now. Now the last couple of things I want to do now is actually take the business logic that we had in our Visual C++ application and transition into here. So if we jump back into Visual Studio, and I'm just going to take the contents here of my on button click, which happens to be rather long. I'm going to copy that, jump back into my designer, open my button, and paste that in. What I also need to do here is, you'll notice that we're using a C string. That's an MFC class, and I want to be able to refactor that and use a standard string class from FireMonkey, which happens to be this guy here. So we've gone and defined our function. There's one last thing I need to do with this, is just above this function call is this method here, which is actually adding my objects to the list box. So I'll copy this also into my application, and we'll make just a couple more slight changes. Obviously now it's not this dialog anymore that's the owner of this method, but my form. It's not a C string but a string, and we'll comment out this line here, and we'll make use of this convention to be able to go and access this particular method. So if we were to run this now, and if we run this now, there's our code, albeit a little crumpled, but you can see here we've been able to move that across. And again, this is only on Windows, so if we change our target platform to OS X and rerun, and we jump over, there's our application in OS X, and there are our objects running there. So just a very, very simple example of how we can take code that's written in Visual C++ that's using some MFC libraries, be able to convert that into C++ Builder and to get that onto OS X. So the next example that I wanted to show you was to talk a bit about web service consumption. We've already written our web services in .NET or in C++ or any of the other languages you might be using. But is there a way I can provide my web service on OS X for my customers? And the short answer is yes, you can. And there isn't as much work compared to that previous example that we just went through. So again, in Visual Studio, if I just jump over into Visual Studio, and close that solution off, and if we go and open our web service, I have a very simple web service here that is simply returning this string. So just something very, very simple. And I'm just going to run this up inside the internal development server. So we should be able to see that running now. I can see my hello world, and there it is. So what we can do now is we can consume that web service directly inside C++ Builder. Keeping the changes never seems to keep them. So we'll close this project now. And I will open up another project. In this particular project, all I have to do is, once I've got my form, in this case, here is my form here. So it's a very, very simple form. I've got the ability now of being able to display in this little, what we call a memo field, the contents of my web service. But the first thing I need to do is to be able to consume that web service. So if I jump into File New, I have this thing here called the WSDL importer. And from this importer, I go and point to where the WSDL for that web service is. And if I need any authentication for it, I can provide that here. I then just want to use automatic SOAP versioning. Otherwise, I can choose the particular version of the Simple Object Access Protocol that I require. And I can also choose from many different options for generating that WSDL. And when I click Finish, what I end up with is this guy here, Web Service 1. Within Web Service 1, I have this method here called Get Web Service 1 SOAP. And within here I define the WSDL that I require with everything else that I need to make that particular call. And really all I need to do is make use of this stub within my FireMonkey application again. And so if we jump back into Hello World and open up my form here, all I have to do is make this call here. Get Web Service 1 SOAP, Hello World. And that will make a call for that and display that within my memo. And so if we now run this, it now communicates to my web service that's running in .NET and displays that into FireMonkey. And I could quite happily, again, switch that over and deploy that to OS X, and I would have that same ability there of being able to access and communicate with that web service, consume it, and add it to the rest of the functionality with my system that I'm building. So, starting to wrap up. A third way that you could possibly interact with FireMonkey as well is by what we call shared libraries. So a shared library is either a DLL on Windows or a dylib on OS X. Now, before we start to do this, there are some rules of engagement that you need to be considerate of if you start embarking down this path. Some of the big differences with FireMonkey as opposed to other frameworks are, the first one is there's no Windows messaging. So FireMonkey has its own message layer compared to things like the VCL and MFC. So if you are combining, say, MFC and FireMonkey, just be aware there might be some conflicts with the messaging that happens under the hood. As I said earlier on, FireMonkey creates all of its own user interface controls. So it doesn't talk to the operating system to create those for me. It creates all of its own UI, it manages all of its own tabbing and focus and so on. And so there's no need to use underlying messaging to support that functionality. The other big thing about FireMonkey is it's not a managed framework, as I said before. So there's no additional installations required, such as a virtual machine or a CLR for mono or any other cross-platform virtualization that you might need. So one of the other ways we propose you could work with FireMonkey is to interoperate with it via these idea of shared libraries. And a shared library could simply contain business logic that's been written in FireMonkey, where we write our DLL or our dylib in FireMonkey. We then compile it to a shared library. And again, the beauty of C++ Builder is that I can choose to either have it as a dylib or a DLL from the one project. I don't need to have multiple projects, all from the one code base. And I can run that on Windows and Mac. Now, in my shared library, if I'm creating forms with FireMonkey, so building user interfaces, on Windows you need to be cautious of GDI+. The way that Windows works, probably all know this, so I'm preaching to the converted, but if you are calling an application that has forms, you might need to also instantiate GDI+. Because FireMonkey uses it already, your calling application will simply need to include the GDI+ header files. And that's enough for it to be able to instantiate it and open up your forms and interact with them. So in my 1 minute that I have left, I hope from my session this afternoon that you understand that FireMonkey is a cross-platform framework where it gives you guys the ability of being able to use your C++ skills to code on Windows, but gives you the additional benefit of being able to deploy on Windows and on OS X. Through this, I also hope you've seen that it doesn't have to be a complete rewrite of your code. You have the ability of leveraging your existing code base where possible. You have the ability of consuming web services with FireMonkey and start creating applications that are cross-platform for your customers. And also being able to use FireMonkey on existing applications by invoking its functionality through shared libraries. Again, thank you so much for having me here this afternoon. I hope you've got something out of the session today. We'll be floating around for the rest of the afternoon. I think everyone has a copy of these slides already. I've made some changes. We can share that again. But once again, thank you very much.